Okay, good morning and welcome to this 5G summer school at Aalto University, Finland. I'm Professor Raimo Kantola from the Department of Communications and Networking. Our department has built the 5G Aalto network, which is a genuine 5G network for education and research purposes. And I'll tell something about 5G so that the topic will become familiar with you. Myself in cloud-based security and trust for 5G and other networks, that's my area. Maybe it gives an angle to what I'm going to tell you today. So I'll get started with what does a mobile network offer in principle, what is the timeline for 5G, why is it needed, and what does it offer to consumers and other users. We look at some industrial use cases because that's the new area in 5G compared to earlier generations of mobile technology. And then there are certain challenges and opportunities and things that are different in 5G compared to previous generations. So they are worthwhile to pay some attention to. So I'll talk about those. So what does mobile network offer? It offers a virtual wire service from the mobile device to the edge of the packet data network, such as the internet or, for example, a private packet data network owned by a company, a VPN of some sort. So communication from device to device is normally not available through the mobile network because we only have a virtual wire. This packet data network is needed in order to connect the two devices. Both 4G and 5G are the same in this respect, while the earlier generations had the circuit switched side of services. And on those services you could communicate from device to device through the network, staying within the boundaries of the mobile network. Okay, in 5G we have a device to device capability, but this is an exception. Normally when you attach to the mobile network, you are using the mobile network itself, and then your packets will flow through the packet data network where you are connected to. So what is remarkable about mobility, it is perceived as very high value service for by the consumers and by all kinds of users. Cost of connectivity nowadays has fallen, and one device can be connected to something with the cost of about €2. This cost is over time coming down, and it has come down in the past, and this will we expect that this will continue until the cost is in the order of 1 cent, 1 euro cent or 1 US cent, or maybe even lower. So the result will be that everything will be connected. Everything that uses electricity will be connected. This is in some time in the future what we expect to happen. Anytime, anywhere communications is of great value to end users, so that's good for the mobile networking. Authentication is a great feature, so all the devices and users that are communicating are known, so faking your identity is not possible. If it were possible, then the mobile network would collapse immediately. You could be telling where I am and you are me, and the operators would not be able to assure anything and even send the bills to right people. Roaming is another cellular network feature, very important. It makes all the mobile operators a family, and they have the same agenda and common interests, and they develop the technology in a reasonable manner as a result. History of mobile generations look like this. Every 10 years approximately we have had a new generation. And what is a generation of mobile technology? It is first of all a marketing campaign like 5G. We have seen a marketing campaign telling everybody that you should have this. It's a great new level of technology, and since we want to sort of be up with the times, of course then we want this new great service. Also, each generation has introduced new frequencies, and it means that new radios, new devices are needed, and new base stations are needed. So there's a lot of hardware upgrades, and when you upgrade the hardware, they are much more powerful than the previous generation devices. Also, leap in bandwidth has been very typical in each generation. So the bit rates that are possible have been increasing tremendously. And as a result, there's a leap in what a user can do with the device. Now, how is 5G different compared to previous generations on this line? Is that the previous generations have been optimized for consumer markets, while 5G is much more varied and diverse. It can serve both the consumers and vertical and corporate markets. The idea that we have generations has helped to increase the pace of technology development, because when you are in sync, the whole industry is in sync, then competition becomes tougher. Capabilities in 5G are appearing in releases. These are something that come out of the 3GPP, which is the organization that writes the specifications for the technology. At the moment, what the last we have is the release 16, which introduced the ultra reliable low latency communications. First package of features for that, and then we are now working on the release 17, and it's expected to, or its goal is to the goal is to get that released sometime in next year, 22. In principle, we have major features like the enhanced mobile broadband. It's already here. Then we have the ultra reliable low latency communications, which is not available to every device, but devices that have subscribed to it. So that's a new sort of like way of using it, and offers new possibilities where 5G can be used compared to previous generations. Slicing is a very popular and very highly hyped feature in 5G. So let's talk more about them. These major use cases are divided in 5G area into three categories. One is that we have very high bit rates on top of this triangle, and extreme mobile broadband is the sort of like use case that we are talking about there. Then there is the bottom right corner here, instant action, less than 1 millisecond latency, ultra reliability are here. So new kinds of use cases and new kinds of devices and services can be offered in this corner. It's more expensive than the previous case because high reliability and low latency, they require more resources than the just high bit rate. And then we have the left bottom corner where we are connecting millions of devices to the network. All right. Then thinking about sort of where the operators and the vendors think that we are going to make money with 5G. On the left-hand side, you see that over the past, say, 5 years, the total revenue generated by the communications industry has been on the level of 1,000 billion euro, right? And it hasn't changed over the 5-year period. Now in the right-hand side of the slide you see different use cases added, and we are talking about billions of euro in factories, in healthcare, smart cities, and so on. So the expectation is that there's potential of untapped need that can be addressed by this 5G technology, and then the revenues out of this 5G technology could be significantly increased compared to previous generations. So this explains why the hype is so high, why so many industry people are talking about using 5G and so on. All right, principles. Looking at the technology a little bit. So what is different in 5G compared to previous generations? The core network, which includes authentication and mobility management and these kinds of things, also connectivity to the internet, managing that connectivity to the internet. So that's core network. It's like the control functionality for the mobile service. This is based on software-defined networking, right? Which we didn't have in previous generations. And it means separation of data plane and control plane, which is a continuation of the drive that has happened over the previous generations from 3G to 4G to now 5G, where we have the cleanest separation of these two planes. The data plane can be based, for example, on OpenFlow. P4 is another technology for switching, completely programmable, where the intelligence can reside elsewhere on the cloud platform. So then the control functions, they are, or actually core functions, all of them, they can be virtualized and they are in containers or virtual machines for that matter, right? We talk about nowadays about cloud native software for the telecommunications industry. Slicing is a new term introduced by 5G. This is the separation of the resources that have been built into the network on low layer, and then dedicating resources to different use cases, assigning the resources to the slice. So, for example, each slice may have its own core network, or the core network can be shared. Some of the, like authentication, it can be shared, but some of the functions, they can be also dedicated to a slice. Each mobile attaches to a slice or several slices depending on its subscription. Also, the radio capacity can be dedicated to a slice. Setting up a slice takes maybe a few minutes, maybe a minute or 2 or 3 or something like that. So it's quite a dynamic thing, but it's not sort of, it doesn't happen in less than a second, right? Let's take a software view on 5G and beyond. So the core 5G software is a cloud software. We talk about cloud native. It is the latest trend in 5G. So in principle, the software that controls the network could run in Amazon Cloud or Azure, Microsoft or similar, but more likely it's going to run on telco cloud. So the mobile network operators are forced to set up data centers of their own, and that's where they will run the intelligence of the mobile network. This way, sort of security and privacy and these kinds of things can be assured much better than using a commercial cloud. But the technology is the same. Then this approach introduces this DevOps process. This is something that all cloud services companies use. They have an agile development process for the software, and then continuation of that process, a cycle is that the new version is deployed and it becomes usable to millions of users immediately. Compared to previous software production process, this is much faster than what we had in 3G and 4G and previous generations. And of course this gives competitive advantage, because whoever is first on the market will earn money, and who is to follow will earn less money. Also, if there are security patches, for example, it's nice to be able to sort of or very good to be able to sort of deploy them quickly. And personally, I expect that also the more widely the use cases where 5G is used will be penetrated by this DevOps approach to software development. This is quite different from automation, and an example of this development is how the most famous electrical vehicle manufacturer approaches the software on a car compared to traditional software approach in the cars. And cars are becoming software products, and if software is deployed using this DevOps approach over the air, then new features can be introduced by purely software without touching the hardware. In 5G, the telecom-specific hardware is limited to the base stations, and then even the packet transport where the packets are sort of moving, that is the same that is used in internet. So these technologies are intermingled, and in mobile networks we rely on the base technology, packet transport technology, that is familiar from the internet. Latency, we talk about low latency services. Why is that important? So in 4G, the latency over the air is from maybe 10 milliseconds to 100 milliseconds, and it varies over time erratically. For example, then net gamers, they take a lower bitrate ADSL service any day compared to 4G because playing over 4G, they get killed in every 10th fight, while they would have survived with ADSL. Augmented reality, virtual reality are services that need a very low latency, otherwise the user would become dizzy. For example, in smart grid we have use cases where really low latency is needed, and it needs to be predictable and assured, otherwise the technology would not be usable. The issue here is jitter or delay variation rather than the delay itself. So long as we have predictable delay, a whole lot of new applications and use cases will open up. In this respect, 5G is expected and planned to be much better than the previous generations. Bitrate, why is that important? This is easily hyped by the operators when they sell their service, but these are some bullets, some of the things why it is important, but let's not get carried away. Then there's this aspect that the highest peak rate is really important for smartphones, because they can really consume most of the time 10 megabits per second, and now we are talking about a gigabit per second download speed in 5G. Of course, there are sort of exceptions when we are doing something like downloading a whole newspaper in the morning to our device, a pad of some sort, for example. Then, of course, the faster network you have, the quicker you have the newspaper on your device. All right. How is then 5G different from the internet? Right? Of course, it provides mobility, but then there are like principles in the internet, like best effort. All the service is best effort, sort of the network is trying its best to deliver packets, but it does not give any guarantees whatsoever. It doesn't even guarantee identity of the user. You can lie who you are, what is your IP address, sometimes, Not always, but sometimes it is possible. It's not a feature of the network that the identity would be assured and authenticated. Security is quite lax on the internet. Lots of hacking happens there. Devices are responsible, and the network doesn't take much responsibility for the security. In 5G, instead of best effort, the network can be tailored to a use case. So some use case can get better service than the other. Identity is assured or guaranteed. A mobile network would not work without authentication. So the operator always knows that this is a legitimate device, and if that device does something bad, it has malware on it, the actions can be always traced back to that device, and there is non-repudiation of the malicious activity. Security in mobile networks is quite decent. We have a hackathon coming up in a couple of weeks where we try to break the 5G security. Let's see how successful the world-class hackers are going to be in this endeavor. Why is it that this tailoring has been introduced into the 5G? It turns out that providing high reliability, high bandwidth at the same time is way too expensive. The high reliability, low latency, they require much more resources than we are willing to assign to just regular internet users, right? It's a question of price. What does the connectivity cost? Does it cost you 10 euro to get a normal package of mobile service over the mobile device, or 100 euro? This is what we are talking about. Low delay, high bandwidth, they have a trade-off between themselves. So idea is that let's choose carefully the use cases that we assign this high reliability and low delay, and hopefully then these use cases are, or somebody is willing to pay for the extra resources that the service is using. Now tailoring originally was a little bit problematic in Europe particularly, and in many other countries, because of this idea of net neutrality. Net neutrality says that the canonic service that everybody is getting is the best effort, right? And you cannot favor other applications over or users over others, right? A year ago, a new ruling in June 2020 came from the European regulator, BEREC, that allows security differentiation and made it more clear that we are able to make use of the best features of 5G in certain circumstances. But still, sort of the net neutrality law is something that sort of restricts ubiquitous usage of 5G features across the board, right? So what is the precisely the conflict between this traditional view of net neutrality and 5G? So if every packet must be treated the same, then this compute element that is part of the 5G can execute one program only, which is ridiculous. It means that, you know, this compute element is useless, right? Now there's some relaxation in the ruling, and we can make progress with 5G. Also, this net neutrality concerns only or applies to internet access service, which means that there's a consumer with smartphone or other device connecting to the internet, and then best effort is the rule, right? If you are doing something else over the network, then this net neutrality does not apply. Okay. the cloud platform, which is inherently needed to provide mobile services, how can more generically the telco monetize that cloud platform, because it's a big investment and requires lots of competence to use it, and it would make sense to sort of try and earn own money on it as much as possible, besides running the mobile network. The compute capacity that is there can be sold to the user. That's one option. It can be sold to the over-the-top provider, for example, Google or Facebook, if they would be willing to buy. And then any program would could be run over that on that telco cloud. If, however, it is so that the telco cloud is under regulation, while the regular cloud, other types of cloud are not under regulation, then of course this will not happen. Then with special regulation, of course, the mobile network operator could execute some extra programs that implement services for the mobile user. But basically, since the same technology is now being used here as by the cloud providers, then there's a need to deregulate telco cloud, and maybe additional steps are needed in this area from where we now are. We now have a basis for making progress in this based on the European law, the new regulation, but this is something to worry about constantly, and maybe make some progress, some more progress in this. How the mobile operator can use this cloud platform for 5G services? Okay. So ultra high bandwidth is very expensive and requires a high bandwidth connection to the internet. That costs a lot of money. So by having local functions and local data, which can be then sent to many users, the need for internet connectivity can be reduced. As a result, the operator can, it becomes feasible to have really high bandwidth to every user, and while if sort of every user has a gigabit and then they are using it simultaneously, the connection to the internet has to be very, very, very high bandwidth indeed. Okay. Then critical infrastructure, public safety might be dependent on the network. This requires a high level of security, and we could use functionality in telco cloud in order to improve the security. This is remains to be seen, but this is something that I have been working with over the past 10 years. Right. Then there's a challenge related to 5G. There's a lot of noise about security and 5G. And more generally, this relates to the fact that when we intermingle and link and interleave the digital world and the physical world and start programming the world, we have a new battleground for the hackers. Right. There's a lot of data to be gathered from the users, and there's a big question: who owns the data? Who builds and manages this interface, and who can hack it? How secure is it per se? It's a very important question. And because you might have a benign temperature the sensor somewhere, and then while we are just reading it as humans that, you know, temperature is now plus 20 centigrade, everything is fine, but when then somebody writes a software system that collects this data and relies on it to do something critical, it's a different matter. Then if the temperature reading can be faked by some hackers, that IT system becomes, it starts using fake information, and things can get nasty as a result. Basically on this interface, because we are talking about physical safety, my advice is that do not connect everything to the internet. That is a fallacy and it's a bad idea. We instead need to sort of isolate things from the internet, and anything that is critical, we should apply some level of isolation from the internet, so that internet-based hacked devices could not be used to attack our services that are on this boundary. This net neutrality regulation and industry structure. Basically, net neutrality is great for the cloud companies such as Facebook, Google, Amazon, web services, and so on. All these great close to de facto monopolies, which are American companies, while sort of the European competition against these companies is at its infancy. We are struggling, and the ones that could do something about this are the mobile network operators, and if they are entangled in regulation, of course, then the situation is not fair in terms of competition. Huawei is in a better position because in China they don't have net neutrality. Slice, what is that? It's a bigger deal than VPN. In principle, it is about isolation of something from the rest of the network, ensuring its quality, delay, and other features. And it is a bigger deal than virtual private network. Virtual private network has one customer who pays for the service, but Slice is something generically, in principle, available to mobile users in 5G. We have industrial use cases where we could dedicate some resources from 5G to the use case, right? We could have radio resources, transport resources, allocated to a slice, and due to software-defined control, resource allocations can be quite dynamic. So if the number of users in the slice at the moment is very low, very few resources allocated, but if now something happens and then we have 1 million users on it, we can dynamically add the resources to the slice within minutes. In principle, we can then add any software functions on top of the regular functions into the slice. Extra security, extra reliability, extra interfaces for data collection, and so on, right? It needs a significant business case. So there's a lot of hype here, but we believe that there are significant business cases where this could be used. And in order to summarize then, what is it that I was talking about? 5G is great for consumers. It's anywhere, anytime, and at homes kind of connectivity. All the net neutrality troubles that we had in the past, they relate to this case. The network operators are hampered in terms of, for example, providing extra security services to the users. If they have to sort of do it for everybody without getting any money for it, they have no incentive to do so. Then we have vertical markets, and this is new in 5G compared to previous generations. Lots of interesting use cases. We have been working, for example, with the smart grid, where 5G connectivity would be brought into the smart grid. All the electrical devices are going to be connected in the long run, and they need to communicate. So one technology that could be used is 5G. Accurate location information with broadband radio that is in 5G would be possibility and could be offered. Possibly this is going to be helpful for automated driving that we are now working on over this coming 10 years. All right, so this was the introduction to 5G, and enjoy the summer school. You'll listen to many other speakers, and if you have any questions, you can send them by email, for example. Thank you.